In this next equation that we need to make, they give us slightly different information once again. But they do tell us that we're going to be writing the equation of a line, which again means that we're going to start out with our point slope form, which is that y minus y1 equals m times x minus x1. So we'll have y minus y1 equals r m times x minus x1. Yeah, we already did A. We're on B now. So what do you need to write an equation of a line in point slope form? You need, again, two things. We need a slope and we need a point, an x1 and a y1. Well, they gave us a point. They gave us the point 2, 4, so we've got half of the information. They didn't directly give us the slope. They hinted at it by telling us that we want something that's perpendicular to something else. Remember, perpendicular lines have certain types of slopes. So we want something perpendicular to this 2y equals negative 5x. Well, first of all, what's this line slope? Well, remember, its slope is whatever's in front of the x, as long as it's in slope-intercept form. The y equals mx plus b, which means I need to solve this guy for y. I'm going to divide both sides by 2, and that will get me the equation y equals negative 5 halves x, which means the slope of this guy is negative 5 halves. Question: is that the slope I want? No. Why? Because we said we wanted something that was perpendicular. What does perpendicular mean? We said perpendicular in the last section meant that the slopes did two things. One, they switched signs, and they flipped upside down. So if this slope is negative, it means I'm going to switch the sign and it will become a positive. But it also needs to be flipped upside down. So 5 over 2 will flip and become a 2/5. So the slope I want is a positive 2/5. So the slope I'm going to use is 2/5, and it needs to be a positive. That's what I'm going to use as my slope, because that'll be perpendicular because it has been switched and flipped. So let's plug this in along with our point into our equation in point slope form. So let's see what we end up with. We end up with y minus our y1, our y from our point is a 4, equals our slope that we want, the one that's perpendicular to the line we have, is 2/5 times x minus the x coordinate from our first point was 2. And that is half of the hard work. We're not done yet, though, because they want us to put this equation in both standard form and slope-intercept form. Now, just like before, either way, whichever one they want, I'm going to have to get rid of these parentheses. So the first thing I should be doing with y minus 4 equals my 2/5 x minus 2 is distributing that 2/5 and getting rid of my parentheses. Let's multiply that out. So I have my y minus 4 that's not getting touched yet. My 2/5 times my x is 2/5 x. Be careful, my 2/5 times my 2, which is 2 over 1. Remember, just like the last one, we multiply our fractions straight across the top first. 2 times 2 will get us 4. And on the bottom, 5 times 1 will get us 5. And it was a positive times a negative, so it's going to stay negative. Now, just like the last one, if you really don't like fractions, you can get rid of them by multiplying everything on both sides by a 5. So what that will do, we'll clear the fractions. We'll get 5y minus 20 on the left, but it'll clear the fractions on the right, giving us a 2x minus, canceling out the 5's again, 4. So now the question would be, which way do you want to split off to conquer first? Do you want to find the standard form, or do you want to find the slope-intercept form? Either way, I can pick up at this point, and I won't need to redo all the work I just did. So let's split them off here. Okay. So let's do standard form first. Remember, what does standard form mean? Standard form means that the x and y are needing to be on the same side. Well, how do I get the x and y on the same side? Well, in this one, I would need to subtract the 2x from both sides, which would get me a negative 2x, and I still have a positive 5y over here. But the 20 that's over here, I don't want it over here. So how do I move that to the other side? Well, it's a negative 20, so I'll add a positive 20 to both sides. So that will get me equals, well, on the other side I've got a negative 4 and a positive 20 now, which will get me a positive 16. Now I am absolutely fine with the equation of this line in standard form, but my guess is my math lab will not like this because the first term is negative. So to get rid of that negative, multiply the whole equation through by a negative 1. That will turn the negative 2x into a positive 2x. It will turn the negative 5 or the positive 5y into a negative 5y. And it will turn the positive 16 into a negative 16. And that is it. That would be your equation in standard form. Okay, moving right along, let's go back to where we split off and let's look at how to write our equation also in slope-intercept form. Okay, in slope-intercept form, that would mean to get the y by itself. So on this one, I'd need to, first of all, add the 20 to both sides to get the y by itself. And that would get me, let's see, 5y equals 2x. And then we have a negative 4 and a positive 20, which would get me a positive 16. And then dividing both sides by 5. Everything on both sides by 5. Let's see what that would get me. It would get me a y equals, well, I'm dividing everything on the left-hand side by 5, so that would give me a 2/5 x plus, let's see, what else do I have? The 16 needs to get divided by 5 as well, so a 16/5. And I know it doesn't look pretty, but the 2/5 and the 16/5 are both fractions that are reduced. So there's nothing else I can do with that. So I am done. That's my equation in now slope-intercept form. So we had to do a little bit of extra work to find the slope by finding the equation of the line that they gave me slope, but then I wanted something perpendicular, so I had to both switch its sign and flip it upside down. Question, what would we have done had they wanted a line that was parallel? Well, had they wanted parallel, remember that parallel lines have equal slopes, which would mean that the original slope that we found in this problem, which was negative 5/2, would have stayed the same. So if they actually say parallel, we just find the slope and use it. If they tell us perpendicular, that's when we have to do the switching and the flipping. So kind of keep